Hello students, welcome to the lecture of Computer Integrated Manufacturing in Automobile Industry. I am Milan Trivedi, Assistant Professor at LJIET Institute of Engineering and Technology. We were discussing about the chapter number 2, that is CNC machine tools. In our today's lecture, our first topic is the constituents of the CNC machine. Basically by this word we actually mean that which are the different basic components we are using in the case of CNC machine. Normally any of the NC or CNC machine will be having this 10 different components. Basically it is having structure, spindle and feed drives, the actuator support bearing, feedback devices, automatic tool changers, tooling, material handling devices, pallet changer devices, lubrication system and the coolant system. So let's begin with the understanding of the first part, that is the structure of the machine. Talking about the structure of any CNC machine, it will be having the 4 basic elements, right? The basic part will cover bed, saddle, column and the table. If we take any machine, these 4 basic structural elements will be common. Whether you take the lathe machine, drilling machine, milling machine, shaper machine, slaughter machine, any machine you take, you will find these 4 basic elements. By the word bed, we literally mean on which all these structural elements are mounted. Starting from the spindle, column, all the basic elements of the machine are mounted on the structure part of the machine. Normally structure material must be heavy, this bed material must be heavy, that's why it is made up of cast iron, right? And normally you are doing the foundation of the bed to the ground so that all the vibrations which is being generated during the cutting operation will be transmitted to the foundation. Saddle is actually the sliding member which is moving on the bed, right? We need to have the movement of either tool or work table on a bed portion, right? So for that we require a saddle. The third basic structural element is a column. Any vertical member you will find in a machine, that is nothing but it is a column. And lastly, you will have a table, right, on which particularly we are mounting either tool or maybe a workpiece, right? So in generalized, any CNC machine will be having these 4 basic structural elements. Now moving to the second constituent of a CNC machine, that is spindle and feed drives. Now we require different kinds of drive in order to have a automatic motion. Up till now we had understand the concept of CNC machine like this, that in order to operate the machine we are writing one particular program. Program is nothing but it is a set of instruction, and as per that different set of instruction, machine tool will be moving. Whether it is a movement of tool or spindle, you will get that automatic movement. But in order to have that movement, we require this different kinds of drives. Starting with the drives, we are having either servo motors or stepper motor basically. In servo, we are having again 2 different categories, that is AC servo motor and DC servo motor. AC servo motors, that is operating on alternating current, we can directly plug into the particular factory premises. Whereas in the case of DC servo motor, we will require an inverter, then only we can use that DC servo motor. Or we can have a battery source even in order to operate a DC source. Now the question arises that if we need an extra element in the case of DC servo motor, then why we need to go for it, right? It is better to use a AC servo motor, but still we are preferring DC servo motor in many of the units. The simple reason is that in the DC servo motor you can fit a controller, you can control that motor very easily. For example, for a spindle drive, if you are using the DC servo motor, you can set RPM very easily. You can control that thing in very easy way. Say for example, if you want to operate a servo motor, spindle motor at say 600 RPM, then that is very easily possible in the case of DC motor, right? That controlling part becomes very easy. Now after understanding that, the next question arises that then why we need to go for AC servo motor? Right. Now the drawback of DC servo motor is that if the apparatus or the force requirement is very high, then the entire apparatus become very bulky. As the force requirement is large, the DC servo unit would be large. So we cannot have a compact fitting in the case of a DC servo motor. So for that, AC is more suitable. So wherever we need to work in a closed loop condition, we are preferring a DC motor. And if we want to work in an open loop condition, we are preferring a AC servo motor, right? Now next motor is a stepper motor. Stepper motor normally works in a 1.8 degree increment. We are having 360 degrees in one entire complete rotation, but this stepper motor works in a 1.8 degree increment way, so we can have a precision control over the RPM part, right? Say for example, if you want to stop the particular shaft exactly after 90 degree, then you can easily do that with the help of a stepper motor. The last motor we can use is a fluid motor. Basically, this works on the principle of hydraulics. A high pressurized fluid will rotate this two mesh gear, and the liquid would be trapped in between the teeth, and low pressurized fluid will come towards the outlet. But in between we will have a motion of this shaft due to the movement of the gears, right? Basically, the force transmitted by this way will be having a high torque. So if high force is required to be transmitted while cutting operation, we can use this kind of fluid motor. The next thing is the actuator support bearing. Basically, we require this kind of support bearing in order to have a frictionless transmission of the force, right? Basically, we are having a motion of shaft with the supply of power driven by the drives, right? If drive is attached to this particular shaft, naturally it will be rotating. But our effort is to reduce the friction between these two different assemblies, right? This carriage and the particular shaft. So we are having that recirculating ball screws in between, which will be recirculated along the surface of the shaft, and it will be easily sliding on the particular surface, right? So carriage can slide easily on this particular shaft with the help of this kind of recirculating ball screws. The concept is very much similar to that of ball bearing, right? Another concept is of linear motion guideways, right? If you want to have a sliding motion in a linear way, then we can use this kind of ball bearings in between. There will be a groove on which we can have a balls which can provide a frictionless surface. So if this top assembly is moving inside this particular groove, in between we are having these balls, and balls are also been sealed. So we can have frictionless movement. So obviously, as the friction is less, the effort required on the drive part would be minimum. So our entire CNC machine become more efficient. The next system or constituent we require is a feedback system. Basically, feedback system is required in a closed loop kind of machine. The reading we are getting is actually just giving you the idea that whatever input you had given, as per that machine is working or not. We can have two ways of working. Either we can have a rotary motion or we can have a linear motion. In order to check the rotary motion, we are having a rotary encoder. The unit is like this. We will be having one LED source which will be passing through the rotary encoder, or we can see it is a kind of a slotted disc. Now the light which is passing through this slotted disc will be having this kind of interface, that light can pass through the particular open slot, and there will be again cutting of that light because of the solid surface. Again the light can pass. So what will happen is, at the other end we are having a photosensor. At the photosensor end, the effect is like this, that is receiving some light, and again there is cutting of that light. It will receive light, then again that there will be a cut in that. So because of that effect, it will generate a squaring circuit or square signal waveforms. What we are actually doing is, how much square signal waveform that is being calibrated with the RPM. That development of this square waveform is resulting into the formation of, say for example, 100 RPM. In that way the unit has been calibrated, or we are finding out the particular RPM value. Again, we can have a linear movement also with the help of same principle, right? We are having one light source, and we need to check, say for about the sliding movement of the tool. We had given 10 mm sliding motion. So whether we are receiving that 10 mm or not, that can be checked by mounting this particular glass surface, right, which is having number of slits in between. LED source will be allowed to pass through that particular slit, and at the other end we will be having a photodiodes. So as they are receiving the light, it will generating the particular square waveform, and based on that we can have a reading of the how much distance this particular surface has been traveling, right? The another element is automatic tool changers. Basically, we are doing all the things in automatic way in our entire CNC machine. This part should also be included, that is the changing of the tool. Normally we are having these two kinds of tool changing devices. The first one is a magazine type and another one is a turret type. Magazine type is very much similar to the particular revolver we are using. In revolver we are having a magazine in which you are mounting different bullets. In a similar way we can mount different tools in a particular magazine. It can be a 6, 8, 12, that kind of magazines are available. Whenever you write in a particular program, say for example T01 number tool must be in the cutting operation. So what magazine will do is that will use the tool number 1 for the cutting operation. Suppose if you are changing tool in your program T02, then T02 number tool will come into the cutting operation, right? So the basic function of the magazine is to hold the different tools. The another format to have this tool holding is a turret type. Normally you had heard about the capstan and turret lathe, right? In that also you had specifically used hexagonal turret which can mount 6 different tools. In a similar way we can have this turret heads in which we can mount different tools like this, right? And the tool number which you have written in the particular program, that will be used for the cutting operation, but that entire operation will be done in an automatic way, right? So that's all about the automatic tool changers. Remaining constituents will be taken in our next lecture. That's all for today's lecture. Thanks for watching.